welcome to Maths Appeal. I am Susan Okereke.
And I'm Bobby Seagull.
And we are on a mission to make maths more accessible to everyone. The Maths Appeal team wants you to get involved, to do more maths. And we as maths teachers know that and believe that everyone can be part of doing maths and feeling confident with it.
Yeah, and the aim of Maths Appeal and our series is just to show people that, you know, maths is really something that all of us can do. It's not really scary, even though it can be tricky. It can be a hard subject, but it shouldn't be as scary as people make it out to be. And this is actually our final episode of season number 2.
And as an extra special treat, we have a special guest, the amazing Matt Parker, aka Stand Up Maths. He is a stand-up comedian and a #1 best-selling maths author, as well as a legendary maths YouTuber. He's got over 1 million followers and he makes incredible maths videos.
He's actually a good friend of Team Maths Appeal. And we actually worked with him on fun things. In particular, Susan, you've worked with him on some sort of knot string mathematical real-life problem.
So I was asked to do a little kind of favour and be in one of his videos, and he got me to learn a quite cool knot trick where I am able to put a ring in a knot and then magically get it out using the magic of maths. So that's something for you to check out too.
So this series, as you know, it's a lot about problem solving and thinking in a mathematical way. And in every single episode, you know the drill. We do a maths problem, we work on it together.
When we set the maths problem, before jumping into doing the maths, we like to set ask some questions to get your mind thinking, to get you in the zone first. So I think a lot of the time it's forgotten that to do problems is quite an emotional thing. So the first questions we ask are, how do you feel when you first saw the problem or heard the problem? Does the problem make sense to you? Do you have any questions about the problem? Anything need clearing up? And what are the math topics in this question?
And then when you're actually doing the problem, firstly, just identify what are the facts that you know. Then secondly, what are the rules and formulae that you need. Then thirdly, are there any sort of almost like facts that you can deduce from the problem? And then finally, are you in a position to tackle the question?
And you know what, Bobby? I'm in a position to tackle the problem. I think it's time for us to get ready. The problem will be with you in a bit. So if you need to get anything before we give you the problem, go get it now. And we'll be back after this. So it's problem time. I hope you're all ready and you're in position and you're paying attention. I'm going to read the problem now. So this is actually a problem from a GCSE predicted paper, and we've adapted it to make it more relevant to us and our audience. So at a charity maths comedy event, comedian A does a punchline every 40 seconds. Comedian B does a punchline every 1.5 minutes. Assuming both comedians start their set at the same time, 0 seconds, work out how long it takes for both comedians to deliver a punchline at the same time. I'll repeat the question one more time. At a charity maths comedy event, comedian A does a punchline every 40 seconds. Comedian B does a punchline every 1.5 minutes. Assume both comedians start their set at the same time at 0 seconds. Work out how long it takes for both comedians to deliver a punchline at the same time.
So we'll come to that in a moment. But first, the moment you've all been waiting for. At the end of season 2, we've got a stand-up comedian, former maths teacher, #1 best-selling maths author, YouTuber extraordinaire, all the way from Australia. It's Mr. Matt Parker.
Oh, thank you very much.
He lives in England now.
Thank you.
Yeah, he lives in England.
Yeah, I do. But I travelled from Australia within the last 2 weeks. So
Wow.
I think that technically counts.
As I think hopefully you're aware, series 2 of Maths Appeal is focused on problem solving. That's kind of the aim of the series. And when we think getting you on, I really, really, really wanted to share your incredible book, Humble Pie, where problem solving goes wrong. Because it's great. And then your incredible Edinburgh Festival show was just great, bringing it to life. And I'd just like to, if you summarise the key points from Humble Pie, please.
Oh, thanks. Yeah, so the book on paper is stories of maths going wrong in the real world. In fact, that was the subtitle in the US edition, because they like to add a more descriptive subtitle when they release it in the States. And so it's literally called When Math Goes Wrong in the Real World in the US. And the idea was, I figured I could use examples of when there's like, all sorts of mathematical mistakes, engineering, programming, measurements, units, rounding, you name it. I found a maths mistake where that went wrong in the real world. And it was kind of an excuse to talk about how important maths is in our modern society by pointing out, first of all, how much maths there is that we normally don't notice, and then what happens when it goes wrong. But kind of behind that, my ulterior motive, what I was trying to feed in there, is that as humans, we're not naturally good at mathematics. Like when we're born, we don't emerge good at maths. We have to learn it.
It's
and
hard
learning
work.
It's difficult. It's hard work.
Yeah, it's
Exactly.
hard work. Yeah, let's not go away from that. It's no one's born being able to get the more you do, the better you become. That's our message.
Exactly. And people get this weird notion that people who like maths find it naturally easy. So I was trying to dispel that a bit. And so while on one hand, I'm aware there's a certain irony here, I'm saying it's important to get the maths right or things go horribly wrong. But at the same time, I was trying to say, look, everyone gets maths wrong. You struggle with it. It's hard to learn. And making mistakes is just part of the process. Don't panic when you get maths wrong. Everyone does. It takes hard work to gradually get slightly better at it.
Do you have one example that you can share from your book? No, like as in, and it can be a spoiler. I just wanted to kind of give people a taste of the type of thing you're talking about, because some of the examples are just amazing, but they're also worth people hearing, because it's one, it's math in the real world, and two, it's the fact that, it's really important, as you say, to get these things right, but people do make mistakes. So do you have a favourite or anything?
Yeah, I do. And it's one with trivial consequences, because there are like ones with big consequences. There was like an airplane where they fueled it and they put in pounds of fuel instead of kilograms of fuel. And so that's
metric and imperial.
Exactly.
We talk about this. Yes.
You've got to use metric units, and then they messed that up. And there's other ones of like people building a bridge, and the different construction teams use different definitions of sea level, and so the bridge was misaligned. At big consequences. The one that I think is less on the consequences, but more insightful, was an advertising campaign that Pepsi ran in the 90s, where they had a joke at the end of this ad that if you collect enough Pepsi points, which you could get by buying Pepsi products, instead of trading them in for a t-shirt or some sunglasses or all these other bits of Pepsi merch, they had a joke that if you ever collected 7 million Pepsi points, they'd give you a Harrier jump jet. This like crazy,
jet?
incredibly expensive jet. And in the commercial, a teenager's flying it to school. It's all very funny. Someone realized that you could buy Pepsi points for 10 cents each. So 7 million Pepsi points was the equivalent of $700,000. And the Harrier jets at the time cost the US military $20 million each. And so they were like, wait a minute. They've dramatically underpriced this jet. And so they got $700,000 to back a check. They sent it in to win the jet. It was a huge court case. And they sided with Pepsi. PepsiCo did not have to give John Lennon from Florida.
John Lennon?
Not the singer's not that hard up.
May he rest in peace.
Exactly. That would be a bad cover story if they're secretly alive. Although Florida, not a bad place, I guess, for it to be secretly. Anyway, either the Beatle or someone with a similar name gave it a go, didn't get their jet, and so Pepsi had to change the commercial. So they changed it to be 700 million points for the hilarious jet. But what I find really interesting is, why did they pick 7 million points? And the only conclusion I can come to is, in some advertising meeting, someone pitched that joke, and don't get me wrong, good joke, good fundamentals. And someone's like, that's hilarious. And they just picked a number that felt big. No, 7 million. Who can even imagine a number bigger than 7 million, right? And they made the classic mistake of relying on human intuition when doing mathematics. And we can't do that, because humans, our brains, famously bad at dealing with big numbers. And they just went, oh, here's a big number, without double checking how big was that number in this context and how big did it need to be. And they just didn't do that. And because of that, they had a very costly court case, and they had to redo an advertising campaign. They almost had to buy a jet. Thankfully, the law sided with the large multinational corporation.
I feel bad for John Lennon.
So
I
do
feel
I.
like
Like,
he did
he
those
should be
hard
having
work.
You should be having the Harrier jet flying to
Exactly
school.
right. Yeah, a lot of
Work.
people
I
think
mean,
John should have got the jet.
Those litigators. So Matt, you've had a really, obviously, I think a really incredible journey from being a maths teacher, I believe in London at one stage.
Yes. And you described me as a former maths teacher.
Oh, you're
in the
still,
intro.
sorry. Once a maths teacher, always a
Well,
maths teacher.
That's what I wondered. I was like,
Sorry.
when? And I
will-
think I felt like I was still a teacher. I was thinking about this as you were saying it. For the first 5 years out of the classroom, I still felt like I was a teacher. But after 5 years, like a whole generation of students pretty much had turned
that's
over.
a good
yeah,
point,
okay, yeah.
generation.
And
Right.
after 7 years, I was like, there's no one I taught is still in the education system. And by then, I think the curriculum had changed as well.
Okay,
Right.
and
yeah.
that's and 7 years incidentally is when every single atom in our body is meant to replace. So that makes sense.
There
Like
you
a new
are.
Doctor Who,
That's-
a new Matt Parker.
None of my atoms had been in the classroom.
That's that's a good definition.
regenerated as it, yeah. So I
Seven.
think you're still definitely a former maths teacher.
But you teach all the time. Like you're, as a communicator, you are teaching maths all the time.
Yeah, but now I do it via bait and switch. Where,
I know. It's true.
yeah, because when you're teaching, the students
Yeah.
have to be there, which is great.
Yeah.
But when what I do now, because you mentioned the Edinburgh Festival show I did based on the book, and I do lots of other stand up, and you've both appeared on our Evening of Unnecessary Detail live nerdy comedy shows, where doing stand up is a subtly different, but not entirely mutually exclusive skill set to teaching, where people, like, I lure them in with the promise of comedy and entertainment, and I hope I still largely deliver on that, but I do definitely switch to just talking about interesting bits of maths, and I will, in the more general, I will, any area of maths, I will stray there, applied, pure, the works. And an audience, even in like a proper comedy club, I mean, it's a bit different when it's my actual show, because that attracts, as you both well know, a very good, nerdy,
Demographic of-
dedicated audience, as well as general people. You can't not entertain them, and you got to have, everyone who shows up, whatever their maths background, has to be involved. But people will go a surprising amount of time if they're engaged and like they're interested before they realize they haven't laughed. So you can do a surprising amount of interesting maths in lieu of jokes before you have to actually, do the thing that people legitimately bought tickets for.
This is interesting. So we're talking about the idea of like maths and comedy and how does it work? Like, do you think the win you have is storytelling? Like, because to go along, you're not standing up there doing equations.
No, and it is storytelling, but it's a more cynical version of that. Because when you're doing a stand-up performance, you're pretty much, you write it almost as a flowchart. So this is particularly like comedy club circuit stand-up, where you're going out in front of an audience who may or may not know who you are, and you're there billed exclusively to entertain them. You will walk out with a flowchart in your head. You're like, right, I start with this joke, and depending on how that joke goes, I either do this joke or I do that joke. And then that will inform what I do next. And I tell this story or I tell that story. Or I tweak, like I tell this story this way or that way, depending on the audience. Then you've got to keep track of what you've already done, where you're at, what you've done with the audience. At the same time, you've got to log like all the interactions with the audience so you can use them later and call back on them. And so a lot of stand-up comedians are closet nerds, because the mental process of writing and delivering stand-up is a very, even acknowledged or not, it's a very nerdy process of how you piece together. And a lot of people just do this naturally. Like they're not I'm literally thinking of the flowchart, but a lot of people are just, they just do it. But their brains are still doing the same processes. So I think the reason I find a maths background is good is you're already kind of used to that style of thinking. The reason teaching's useful for any teachers who are listening and are considering a career change, I mean, don't, but if you're considering it, is teaching. You've spent so many hours talking at a group of students while simultaneously working out what you're saying and what you're doing and thinking ahead, while monitoring what everyone in the room is doing, and altering what you're doing based on just a general sense of how well the audience are following along. And that skill takes a very long time to learn if you're learning it on the open mic circuit doing stand-up. But if you've already been teaching for a few years, you've had to learn that skill because you've been...
Reading the crowd.
Reading the crowd while still delivering your material and adjusting your material in this nice little feedback loop with your reading of the crowd.
I love this. The problem-solving setup of comedy. Wonderful.
Yeah. That's a great way to put it.
So now it's time to return to our puzzle and see how you've got on. Bobby, you ready? Matt, you ready?
I'm ready.
As a reminder, the problem is, at a charity maths comedy event, comedian A does a punchline every 40 seconds. Comedian B does a punchline every 1.5 minutes. Assume both comedians start their set at the same time at 0 seconds. Work out how long it will take for both comedians to deliver a punchline at the same time. Before you do any maths, remember, no maths to be done to begin with. If the questions you're asking yourself are, how did you feel when you first saw the problem? Bobby, how did you feel?
So in my mind, I was like, oh, and just to tell people, this question came from a GCSE, was it foundation question or?
It's one of those early part of a higher one, but then also foundation.
Yeah. So I think the first thing I was like, this sounds like a question that my year 11 students would love doing. Genuinely, that's the first thing I thought.
Oh, you think they enjoy it?
They like things where there's a method. And I think, this is one where there's a clear method that I've taught them.
Okay, on the flip side, my view is generally with these type of ones, I hate lists. I'm like, I don't think it's a straightforward workout. I'm just thinking you've got to list some numbers, but that's okay. I can manage that. How are you feeling, Matt, when you saw it recently?
That is a long time between punchlines. So I just...
You're thinking in real terms.
They've been roped into some charity event, so... They're like, we'll do it, but we're not going to do many jokes. Yeah, you'd be doing way more frequent jokes if you were on stage. But hey, if they can get away... I mean, maybe people who see my shows think I'm being very hypocritical at this point. But they're pretty spaced out. I like it. I got to lower my standards.
Okay, this is good. What's good about this is you brought it into the actual real world now. And it's not a very bad question. I think it's actually quite a good question. And so any kind of problems, any kind of questions about the problem, maybe kind of understand the basic gist of what's kind of going on with regards to it. And what maths topics then are in it, Bobby?
So, I guess it makes sense because sometimes the questions, problems we've done, GCSE maths problems, sometimes they're not entirely clear the approach. Whereas this one, I feel as if all students should have been taught there's a couple of clear ways of solving this. And for me, it's like, LCM, lowest common multiple. So hopefully then students are like, I've got this.
Yeah, I'm hoping the same. So lowest common multiple, but in a way that I just think, even if you don't think of a lowest common multiple, you're just thinking when things come up at the same time. It's noticing things at the same time. So what facts do we know about the problem? What are the key things we need to be aware of here?
I guess it's like in Matt, with your students, did you get them to underline or work out what the key bits were, like 40 seconds, minute and a half?
Skip through, find all the relevant, find all the irrelevant information. Make sure you've highlighted it or circled it or something.
Right. So I'll keep it information every 40 seconds and then every minute and a half. And so what do you think we need to do then? So with the maths of this, what are the key things to be able to work this out? What do you do, Bobby? Talk us through your steps.
Method. So I love prime factor trees.
Oh, really?
Yeah, with my year 7s, like one of the, I was like, it's so cool. Like, as my students are obsessed by drawing the trees.
Should I just say what I've done? Because I'm interested where yours goes. I feel like I might have done the way that most people have done it.
Normal people,
yeah. Not that you're not normal, but at the same time, yes. So what I did was I had 40 seconds on one list, and then I converted 1 minute and a half to 90 seconds, and I just effectively just kept adding up, adding on 40, adding on 40, adding on 40, then adding on 90, adding on 90, adding on. I did like quite a few for 40 because 40 is quite small compared to the 90, and then I added on 90, and I realised for both lists keeping on going, the first time they cross over is with the number 360 appears in both lists. And that's where there's going to be a joke at the same time. So that's when, if you're in different rooms, you'll hear both rooms laughing at the same time in 6 minutes.
After 6 minutes, yeah.
Yeah, that's kind of how I did it.
Matt, is that how you'd have solved it?
I first of all thought of the way you were going to do it, Bobby. I don't want to spoiler yours, but then actually, you know what? Do you want to give us yours, Bobby? Because I thought about your method, but then another one occurred to me. But I just wanted to check that I'm on the same page with what
Okay,
you
so
did.
I initially split up the number 40 and minute and a half, 90 seconds into a product of its prime factors. And again, product is just the multiplication of, and prime factors are the numbers that are prime numbers that if you multiply make up 40. So 40 is 2 times 2 times 2 times 5. So it's 2 cubed times 5. So that's 8 times 5. That's to make 40. And then for 90, it would be 2 times 3 times 3 times 5. That's 2 times 3 squared times 5. So all I've done is split up those two numbers into the product with its prime factors. Is that sort of the way that you started doing this problem, Matt?
Yeah, so I did the same thing. I wrote out the prime factors like you just said, and then I went through and I was like, okay, what collection of these do I need? So I include each of them separately. But I imagine you've got a better way of describing that.
I think that's, to be honest, the same way. Like, so each prime factor, you find out where it occurs most often as a factor, and you write it down that many times in a new list. So in this new list, they've got 2, 2, 2, 3, 3, 5, which is, so essentially where they overlap, sort of.
Sort of.
Yeah, because that contains both sets of prime factors.
Yes.
So it's a multiple of both the numbers.
And then you multiply that, 2 cubed times 3 squared times 5, which is 8 times 9, which is 72. And 72 times 5 should give us 360. 6 minutes for lots of laughter.
Okay, so you did prime decomposition of 40 and 90, and then effectively you got your prime numbers and you multiplied them all together. The overlapped ones you didn't repeat, but you then multiplied all those together. Right, for some people, they might be like, prime decomposition, what are you talking about? But it's not a difficult thing. It's worth looking up because our prime numbers, we're going to spend a bit more time on this in the future, I think. They're amazing. They are effectively the backbone of our number system, aren't they? Which we don't spend enough time playing around with.
Oh,
So I did the list and Bobby and Matt went into the hardcore mathematics.
Well, I then didn't do that.
Oh.
Because then I looked at the question and realized it says work out how long it will take for both comedians to deliver a punchline at the same time. It doesn't say the first time.
Oh.
And I was like, well, if I don't have to work out the first time it happens, I don't need the lowest common multiple.
Right.
I just need a common multiple. And I was like, well, the easiest way to get a common multiple is just to multiply them together. So I just multiplied 40 by 90, which is 4 times 9. So I got 36.
Yeah.
And then put the zeros back on, 3,600. And so what's great is comedian B, that tells a joke every 90 seconds, would have told 40 jokes by then. And comedian A, which tells a joke every 40 seconds, would have told 90 jokes. 3,600 seconds is exactly an hour. And I was like, they've both been booked to do a 1 hour set.
Oh, this guy.
Right?
Yeah.
And obviously you want to end on a joke. And so they both picked their rate of punchlines. So they both end simultaneously on a big joke right at the end of their 1 hour routine.
They
Thank you
raised
very
the
much.
roof.
Good night. Make sure you pay,
that's
give generously to charity. Then that's what is a math comedian if not one who perfectly calculates the rate of punchlines to finish on a big gag.
You've taken it to the next level. Wow. So, thank you, Matt and Bobby. We're almost there, but not quite there yet. We always finish our episodes with a math fact from our Bobby Seagull. So, what have you got for us this week?
So this week, actually, it's not really a fact. It's more like a bit of trivia. So you've heard of Times Table Rock Stars. So this is like a online quiz that students can take part, times tables, division challenges. And I think at the end of 2021, early 2022, there was a challenge. And a student called Brooke Cressy, she's 8 years old. So she answered a series of these online division and multiplication questions. And in 1 minute on her phone or tablet, she answered a world record 210 arithmetic questions. I can't even type 210. I've seen a video of her. In fact, we'll probably share a link. This girl called Brooke Cressy, 8, answered 210 arithmetic questions in a minute. It's like she's literally like in a trance, like it's incredible how it's almost like you need like some sort of like super mechanical, let alone like the brain seeing the numbers.
She's not a robot. She's a real person.
She's a real person. 210 questions in a minute.
Wow.
I know it's not a fact, but it's like, well done, Brooke Cressy.
Well done. That's kind of incredible. Maybe that's the future of kids, kind of being super quick on the times tables. Maybe not. Depends on the kid, I guess. Oh my God. Thank you, Bobby. That's like, I need to see that video, and I haven't seen it, so I need to see that. Always a pleasure. Thank you for sharing your maths facts. Also, we want everyone to get involved with sharing their math solutions. So we've got solutions from me, solutions from Bobby. We've got a solution from Matt as well regarding our puzzle. We would love to see whether you have done the questions in the same way. So please share on Instagram or Twitter, and we will kind of comment on that. And please as well tell your friends about Maths Appeal.
Thank you so much, Matt Parker, for joining us from, I was going to say from Australia, but yeah, from Australia, now England.
Maths is everywhere. Come on.
Maths is everywhere, even the other side of the world. And if listeners, you've enjoyed listening to Matt's voice, obviously, you can see his real face on YouTube, on his YouTube channel, Stand Up Maths, or his podcast with Beck Hill, A Problems Squared.
We have had such fun in this series. We'd love to hear more from you. The music was composed by Kelly Okereke, the image designed by Calix Davis, and a massive thank you to the producer, our producer, Jenny Nelson. And we hope to see you all soon for season 3 of Maths Appeal.